Welcome to this episode of Robert's Creative Chronicles. Today we are going to solve this question, which states that draw shear force and bending moment diagrams for a cantilever beam of span 1.5 meter carrying point loads as shown in the figure below. So here is the figure. So to draw a shear force and bending moment diagram, we have to calculate the magnitude of the shear forces and the bending moment at each section. So first we are going to do the calculation. So let's start with the shear force. So we will calculate the shear force at each section, which is B, C, and A. This point A is the fixed end of this cantilever, and point B is the free end of the cantilever. So a cantilever has 2 points, fixed and free end. So this one is the free end, this one is the fixed end. So you can see it's fixed here. So let's start by calculating the shear force at B. But first, I want you to know that there are 2 weights, there are 2 point loads. So let's say W1 to represent the first point load, which is 1.5 kilonewton, and W2 to represent our second point load, which is 2 kilonewton. So to calculate the shear force at point B, it will be any force that is acting downward, we are taking it as negative force, and anyone that is acting upward is positive. So since this point load is acting downward on the beam, we will say it's negative W1, which is negative 1.5 kilonewton. So this is the shear force here at this point. Now the shear force at C is the combination of the shear force here plus the shear force here, because at this point the force at this point is more than the force at this free end. All the forces on this beam, the magnitude will be applied at this edge, because here is fixed. This is the point that will feel the weight of all these point loads. If there are many, as there are 2 point loads here, these point loads, the magnitude will be felt at this point A, because it is fixed. So at this point here will be the addition of this force and any other force before it. So if you are going like this, it will be the addition of this force plus any other force that is before it. So this 1.5 is before this 2 kilonewton. So it is given by negative W1 plus W2. If there were another third one, plus W3. So now it's what? Negative 1.5 plus 2. So my FC is what? Negative 3.5 kilonewton. And since there's no other force here, the force at A, that is the point load, the shear force at A is automatically minus 3.5 kilonewton. So the magnitude of the shear force at point A is negative 3.5. So this total force we felt here. So we are done with the shear force calculation. Now the bending moment calculation. So we'll start with the bending moment at B to be MB. to represent our bending moment, M to represent our bending moment. So at this point, the moment at this point is negative Wx. We know that x at this point, x is 0, the distance is 0. So x is 0, the weight is okay. The weight now is this W1 because 1.5 is the W1. So you can say negative W1 x. So the weight is negative. So it will be negative 1.5 times 0, which is equal to 0. So the bending moment at this point, B, is 0. It is a free end. The bending moment at the free end is always 0 in a cantilever. So this is the reason, because distance is 0 there. So the bending moment at point C is what? At this point, the bending moment is the force acting downward times the perpendicular distance from that point. So here is the force, W1, negative W1 times what? This distance, x, which is what? Negative 1.5 times 0.5. So my MC is now what? 1.5 times 0.5 is 0.75. Negative 0.75 kilonewton meter, since it's moment, bending moment. So you see, this is my moment at C, my bending moment at C, at this point C. Now, the moment at A, MA. My moment at A will be the sum of all the moments from this point. It will be the first moment is this times the distance, perpendicular distance from this point, and also this times the perpendicular distance from this point. So, since the force acting downwards is negative, open the bracket. Okay, negative, open the bracket. Then is W what? W1 times what? W1 times L. L is the whole length. Times L plus, open bracket what? W2, which is 2. W2 times what? The distance from here to here is 1.5 minus 0.5. So it will be L minus X, then close bracket. So now let's substitute the value. Negative W1 is what? 1.5 times L is also 1.5. That is the total length of the beam. Plus what? What is W2? W2 is what? 2. From the equation is 2. Then L is what? 1.5 minus 0.5. So let's just put this in the calculator. 1.5 times 1.5 plus 2, 1.5 minus 0.5 equals what? 4.25. So the answer is what? Negative 4.25 kilonewton meter. So this is our bending moment at point A. So we have done the calculation. Let's move to the diagram now. So now to draw the shear force and the bending moment diagrams, you project these points. Any point they give you, if it's 4, 5, this one is 3 points, you project all of them downward, straight. So next, you draw a horizontal line, okay, like this. So after that, you look at the above point roads. The point road here is 1.5 kilonewton. So that means you move down 1.5 to represent this point road. You move down 1.5. You can use a scale. Maybe you can say 1.5 kilonewton to represent 1.5 centimeter. You can also use a graph while you're doing it. If you actually want to do the measurement, you take a scale. This is kilonewton. Kilonewton is just a unit of force. So it's not a distance unit. So you take it to represent a distance unit and you move down by the distance. So, but let's assume that my distance is just so this 1.5 kilonewton. So you move down distance to your scale, according to your scale. You can actually move down 1.5 like this. You see? So this is 1.5 centimeter. Then, since it's a cantilever, there's no point road here. You move horizontally onto the next point. There's another point road. So here there's a point road 2. So you move down a distance to represent 2 kilonewton. If I'm still using the scale I want to, maybe 2 kilonewton to, since 1.5 kilonewton to 1.5 centimeter, that means 2 kilonewton will also represent 2 centimeter. So from here, I can move down 2. You see, 2. The distance of 2 to represent this. Then finally, you move horizontally and then you close the curve. So this is the shear force diagram. You can write shear force diagram. So the distance from here to here and here to here and here to here. So here's my shear force diagram. The distance from here to here is 3.5. Can be centimeter or millimeter or inches, any scale you want to take. So I just took a scale of a 1 centimeter to 1 newton, 1 kilonewton, sorry. I just took a scale of 1 centimeter to 1 kilonewton. So anything is equivalent to the centimeter. If it's 2 kilonewton, it's 2 centimeter I'm using. Well, that's how, here will be 3.5 centimeter if you measure it. So, but you can also do a rough sketch. The main thing is to get the idea of how to draw the diagram. The scale is not a problem. You can draw it to any scale you want. So let's now do the bending moment diagram. This is the shear force diagram. So the bending moment diagram, in the same way you draw a horizontal line. Yeah. So now at this point MB, my bending moment is 0. You mark here 0. So at the second point MC, my bending moment is negative 0.75. You come down here 0.75, here 0.75. You mark it downward. And then the third one is minus 4.25. So you come here, minus 4.25 is here. So you mark it. and you come, you join them by straight line curves. So I join this point first. I join this point first to here, then this point to here. So this is my, and you close it. So this is our bending moment diagram. And remember that at this point is A, then this point is C, this point is B, just as above here. Again, here also, here is B, here is C, and here is A. So here the distance down is what? 0.75. Then here, so here is 4.25. So this is my bending moment diagram. So this is our bending moment diagram. I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email it in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share, and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.